Hey guys, and welcome back to another video on the channel. In today's video we're going to do a part 2 to the geometric sequence video. So in the previous video we took a look at these questions here where we pretty much went over what a geometric sequence is and how to calculate terms for them. Pretty much this is just a follow-up video, and let's get straight into it. So example 5. Georgina draws a pattern consisting of a number of equal lateral triangles. The first triangle has side lengths of 4 centimeters, and the side length of each successive triangle is 1.5 times the side length of the previous one. So she's basically drawing triangles and they're progressively getting bigger. And the factor they're increasing by is, what is it, 1.5, so 3 on 2 pretty much. So times by 3 on 2 times by 3 on 2. So 1 plus a half is the same as 2 on 2 plus a half, so that gives you 3 on 2 if you don't know where I got that from. So that's 1.5 really. So we can see it's kind of a geometric sequence. So the first triangle has side length of 4 centimeters, so we have 4. If we times that by 3 on 2, that should give us the next term. So we would have 4 times by 3 on 2, which is going to be 12 on 2, which is 6. So we can replace that with 6, just so we get an idea of what these triangles start to look at. Then you times that by 3 on 2 again. So you're going to have 6 times by 3 on 2, which is going to give you 3 times 6 is going to be 18 on 2, which is 9. So then it's going to be 9. So this is kind of the pattern we have starting to appear. Okay. What is the side length of the fifth triangle? Okay, so we've worked out what our R is, and we've got the first term. So we know our R is 3 on 2, and we know our first term is 4. So we have T of n equals T of 1 times by R to the power of n minus 1. So we're going to go, alright, T of n is going to be 4 times by 3 on 2 to the power of n minus 1. And they wanted the fifth triangle, so that's going to be T of 5. So we'll go T of 5 equals 4 times 3 on 2 to the power of 5 minus 1. So we'll have 4 times by 3 on 2 all to the power of 4. So if you put that in your calculator real quick, you have 4 times by 3 on 2 all to the power of 4. And that gives you 81 on 4, which is approximately, if you do your calculator, 20.25 centimeters. Okay, so we can see at the moment it's whole numbers here, but slowly, progressively, we're going to get funny looking numbers like this. Okay. Now B is asking which triangle has a side length of this. Okay, so they've given it to like this. So 45, 9 over 16. What's that as a decimal? So in other words, the side length where it's 45.5625. So I just plugged in my calculator 9 over 16 and gave me 0.5625. Okay, so that's where you got your 45 point something from. Let's not rub that out. Let's rub this stuff. Oh, actually no, we might need that. Rub this out. We don't need this anymore. So what we're going to do is, alright, we're looking for our side length. So we're looking for an n pretty much. So your n tells you triangle. So for example, that was the side length when n equals 5, so the fifth triangle. So we're just going to make this equal to T of n. So we'll have, alright, 45.5625 equal T of 1, which is 4 times by 3 on 2, all to the power of n minus 1. And now we're pretty much going to solve for n. So divide both sides by 4, so we're 45.5625 over 4 gives me 3 on 2 to the power of n minus 1. 45.5625 divided by 4 gives me 11.390625. Now, if I can rewrite that as a fraction, I'll use my calculator. 729 over 64. So we have 729 over 64 equals 3 on 2 n minus 1. Okay, so now I'm going to rub this stuff out because I've run out of room. And what we're going to do is a little index law trick. So in the previous video I established, okay, so if you have a to the n times by a to the m, you can add the indices. But you can also do the reverse. So for example, if you have 2 to the n minus 1, that is the same as 2 to the minus 1 times by 2 to the n. So here when we have 3 over 2 to the power of n, minus 1, that is the same as 3 over 2 to the power of n times by 3 on 2 to the power of negative 1. Okay. So what we can do there is simplify that side. So I'm going to rub this out to have a bit of room. So I have 729 over 64 gives me 3 on 2 to the n to the power of negative 1. So if it's negative 1, all I'm going to do, so this guy will just turn into 2 on 3. All I'm doing is flipping it, so times by 2 on 3. So now I'm going to move it to the other side, so I'll divide by it. So I have 729 over 64 times by 3 on 2 gives me 3 on 2 to the n. Okay, I'm going to multiply this side, so I have 729 over 64 times by 3 on 2, and that's going to be 2,187 on 1 to 8 equals 3 on 2 to the power of n. Okay, righto. So basically we've got to equate the top and bottom. Okay, so in order for this to be true, this ratio is going to be equal to this ratio to the power of n. Okay, so if I distribute my n, I'm going to have 2187 over 128 equal to 3 to the n over 2 to the n. Okay, now you can't really equate the top and bottom because it's not necessarily they'll be the same, but I do know from the previous example we did up here, I don't know where it is, that 28 is the same as 2 to the power of 7. So what I can do is check a couple of things. Alright, if 28 is the same as 2 to the power of 7, is 3 to the power of 7 equal to 2,187? Yes, it is. So what I can do is rewrite that as 3 to the power of 7 over 2 to the power of 7. So therefore n is equal to 7. And that is our solution. So triangle with a side length of this is the 7th triangle. Okay. I hope you enjoyed that little question. If you had any questions about that, leave something in the comments and I'll try my best to answer it. Let's go into straight some questions now, so no longer examples. Let's get straight into it. So find the specific term in each of the following geometric sequences. So for example, we've got this one, so t of 1 is 2. On my r, we can see I'm increasing by 5, so times by 5. And we'll ask for the 7th term. So t of n equals t of 1 times by r to the power of n minus 1. So we're going to have t of n equals 2 times by, oh sorry, that's an equal sign there, not times, is equal to 5 to the power of n minus 1. T of 7, so 2 times by 5 to the power of 7 minus 1 gives me 2 times by 5 to the power of 6, which is, how many is that? Oh, that's a big number. Anyway, gives you this term here when you plug into your calculator, so I'll put that there. 31250. Okay. It's pretty basic stuff, and you do this with every single question. So let's take a look at question B. So question B is a bit funny because it's got fractions in it, but all you got to do is try and look for something in common. Okay, so if we want to find r, we take our previous term and divide it by itself, because if you remember, in the previous example that we did, wherever it is, up here, if you want to find r, you take the previous term and divide by the next term. So in other words, r is the same as t of 2 divided by t of 1. Okay, so if I move that down, r is t of 2 over t of 1. So I know t of 2 is 5 on 7, and I know t of 1 is 15 on 7. So in other words, r is going to be 5 on 7 divided by this, which is the same as timesing by 7 on 15. So in other words, cancel the 7 out. So r is going to be 5 on 15, which simplifies down to 1/3. Okay. So if we take a look at this, all right, 15 times by 1/3, what does that give you? 15 over 21. If you simplify that fraction down, you're going to have 5 over 7 because you can take a factor of 3 out of both of them. Okay. So that's your r for that case there. So r is 1/3. But that's not the question answered because the question's asking for the 6th term. So, rub this out now. So t of 6 is what we're trying to find. We've got t of 1 is 15 on 7, and r is a third. And we have this formula here. So t of n equals t of 1 times by r to the power of n minus 1. So therefore we have t of n equals 15 on 7 times by a third to the power of n minus 1. Then you're going to plug in 6. So t of 6 is 15 on 7 times by a third to the power of 5, because 6 minus 1 is 5. So you have 15 over 7 in your calculator times by a third, all to the power of 5. And you should get 5 over 567. Okay, so t of 6 is 5 over 567. Okay, righto. Now the question C is a bit interesting because it's flipping between positive and negative. So that means our r is a negative number, because a negative times a negative is a positive, but a positive times a negative is a negative. So we know it's going to be negative, and we can see straight away what it is. To go from 1 to negative a quarter, you need to multiply that by negative a quarter. And it works here as well. So if I want to go minus a fourth, I times that by minus a fourth. That's going to give me positive 1 over 16. So we found out what our r is. It's negative a quarter straight away. Okay. Our first term is 1. Pretty easy. And now we go find the fifth term. So t of n equals t of 1 times by r to the power of n minus 1. So you're going to have t of n equals 1 times by negative 1 on 4 to the power of n minus 1. So you can actually just write it as negative 1 on 4 to the power of n minus 1. Then you're going to put in n equals 5. So that means we're going to have t of 5 is negative 1 on 4 to the power of 5 minus 1. So negative 1 on 4 to the power of 4. Then you just put that in your calculator. So go negative 1 on 4 to the power of 4 gives me 1 over 256. So I go 1 over 256, and that's it. Okay. So now we rub this out, and we take a look at D. So D looks a bit interesting, mainly because there's no really obvious numbers that's happening. But now we just got to look at it pretty in detail. So we're going from a of x to a of x plus 1 and a of x plus 2. So what's happening is these are being increased by powers of 1. So if you remember, if you have a to the m times by a to the n, and these are the same, you can add their exponents. So what's happening is pretty much, alright, a to the x times by something gives me a to the x plus 1. Wouldn't that just be a to complete that sum up there? And then if you have a to the x plus 1 and you times it by a to the 1, that'll give you a to the x plus 2. So we can see our r is times by a. Okay. So r is a, and our first term is a to the x. Now it looks a bit weird because we have x's in there, but it's exactly the same process as the previous questions. So now we'll rub this out. So we have t of n equals t of 1 times by r to the power of n minus 1. T of n equals a to the x times by a to the power of n minus 1. And then we want the sixth term, so n equals 6. So t of 6 equals a to the x times by a to the 6 minus 1. So therefore t of 6 is going to be a to the x times by a to the 5. So therefore you're going to have a to the x plus 5 is your sixth term. Hopefully that made sense. If you have any questions, leave something in the comments and I'll try my best to answer them. But let's move on to the next question. Okay, so find the common ratio for the following geometric sequences. So the first term is 2 and the sixth term is that. So 486, sorry. So t of 1 is 2, t of 6 is 486. So we have t of n equals t of 1 times by r to the power of n minus 1. So what we're going to do is replace this with t of 6. So t of 6 equals t of 1 times by r to the power of 6 minus 1. I know what this is. They've told me right there. And I know what this is. They've told me right there. So I'm going to have 486 equals 2 times by r to the power of 5. divide both sides by 2. So 486 divided by 2 is going to be 243 equals r to the 5. Now this isn't going to be a whole number, I don't think, so r to the 5 is 243. So all you're going to do is take the fifth root of that, 243. I don't know what that's going to give you actually. Let's double check. 243. Oh, well, you know it's 3. Oh, good. Right, so the common ratio is here, so r is 3 for that sequence there. Now they've said geometric sequence, so you can use that as a geometric sequence, unless they specify the sequence. If it's being multiplied by a constant amount, you should know it's geometric because that's the definition of it. And let's do question B. So it's the exact same as question. So t of 1 is 25 in this case, and they've given us the fifth term is 16 over 25. So what I'm expecting is an r less than 1 because you can see the numbers decreased. It's gotten very small over time. So we have t of n equals t of 1 plus times by r to the n minus 1. So what I'm going to put here is the fifth term, so t of 5 equals t of 1 times by r to the power of 5 minus 1. Here I can replace with this number here, and here I can replace with that number there. So I have 16 over 25 equals 25 times by r to the power of 4. So I have 16 over 25 equals 25 r to the 4. So what I can do is actually divide both sides by 25. So I have 16 over 25 squared equals r to the 4. So what I can do is actually take the fourth root of both sides. So r is going to be the fourth root of 16 over 25 squared. Plug that in your calculator. So I'm going to go fourth root of 16 over 25 squared, and that gives me 2 on 5, which makes sense because it's an r less than 1, so it makes sense why it's decreasing now. 2 on 5. Okay. If you have any questions about that one, leave something in the comments and I'll try my best to answer them, but let's move on to the next one. Okay, a geometric sequence has a first term of a fourth and a common ratio 2. Which term of the sequence is 64? Okay, so t of 1 is 1 on 4 and r is 2. So we don't know what this one is, so t of n is 64, and we want to know what this n is, okay? So we write our formula, t of n equals t of 1 times by r to the power of n minus 1. We can substitute this for that, and the following expressions here, so this for that, and this for that. So we'll have 64 equals 1 on 4 times by 2 to the power of n minus 1. Okay, now we've got to solve for n. Okay, so multiply both sides by 4. So 64 times by 4 is going to be 256 to n minus 1. 2 to the n minus 1 is the same as 2 to the n times by a half. So if I double this side here, so I'll have 256 equals 2 to the n times by a half. So if I times by 2, it'll cancel that side out. And times by 2 over here it doubles that side. So 2 times by 256 is 512 equals 2 to the n. Now, this one's going to be a bit trickier to work out, but you can do this without logs. So, what we're going to do is use stuff we already know. For starters, we know 2 to the 3 is 8, okay? Work out if it's divisible here. 512 divided by 8 is going to be 64, so we know that 8 times by 64 gives me 512, okay? 8 is the same as 2 to the power of 3. 64 is the same as 8 times 8, so it's 2 to the power of 3 times by 2 to the power of 3. So we can see if we add up those indexes, we have 2 to the power of 9 is 512. And you can double check that with your calculator as well. So if you put in 2 to the power of 9, it should give you 512. So what we have is 2 to the power of 9 is equal to 2 to the power of n. So therefore n is 9. So 64 is the ninth term, so t of 9. Okay. If you have any questions about this one, leave something in the comments and I'll try my best to answer it. But yeah, pretty straightforward, this question here. Right, let's take a look at this one. Okay, so The number of fish in a breeding tanks of fish farm are follow a geometric sequence. The third tank contains 96 fish, and the sixth tank contains 768 fish. So that means T of 3 is 96, and T of 6 is 768. Okay, how many fish are in the first tank? So we gotta use this formula here and update it. Okay. So what we can do is replace the 1 with a k, as long as this term is before this term here. So we can rewrite this as T of n equals T of k times by r to the n minus k. So what I can put here is, alright, this can be T of 6, and this can be T of 3 times by r, and replaces n with the 6 and the k with the 3. I know exactly what this is. I worked it out here, or actually they gave it into the question, and I know what this is as well. They gave it in the question as well. So what we have is 768 equals 96 times by r to the 3. So 768 divided by 96 gives me r to the 3. 768 divided by 96, what's that? 8 is r to the 3. So cube root that, and you should get 2. Okay, so your ratio is 2, and we haven't found anything else yet, but we can find the first term now. So if we rub out all this stuff here, we now want to know what r is, so now we can use this formula here. Okay, and we can choose either term here. So in this case here, I'll choose T of 3, so T of 3 is equal to T of 1 times by 2 to the power of 3 minus 1. I know what T of 3 is, it's 96, equals T of 1 times by 2 squared, which is 4. So I have T of 1 equals 96 divided by 4. 96 divided by 4, what's that? 24. So there are 24 fish in the first tank. Okay, so I'll write that up here. So T of 1 equals 24. Now we'll rub this stuff out, because we don't need it anymore. And now it's asking how many fish are in the 10th tank. So now we can just use our normal formula. So T of n equals T of 1 times by r to the n minus 1. So n is going to be 10, so T of 10 is going to be 24 times by 2 to the power of 10 minus 1. So it's going to be 24 times by 2 to the power of 9, which gives me, wow, that's a lot of fish. 1, 2, 2, 8, 8 fish. Okay, we can see, yeah, it's getting doubled all the time. But yeah, that's a lot of fish. But that's how you'd answer that question there. Pretty straightforward. It's just the application question of a geometric sequence, but not too shabby. Right, let's handle this one. So the Tour de Mova is a cycling event which lasts for 15 days. On the first day, the cyclist must ride 120 kilometers. So straight off the back, that's your first term. And in each successive day, they ride 90% of the distance of the previous day. So that means it's decreasing. Okay. So for example, if we can work out 90% of 120, 120 times by 0.9. I actually don't know what that is. 9 is 108. So it's going from 120 to 108. And then the next day it's decreasing as well by 90%. So to 97.2. They must ride the distance. Okay, so it's decreasing by 90%, so it's getting multiplied by 9 on 10 each time. Okay, so we can kind of see it's slowly decreasing. How far do they ride on the 8th day? So we go R is 9 on 10, and T of 1 is 120. So T of n equals T of 1 times by R to the power of n minus 1. So we want the 8th day, so n is 8, so T of 8 equals 120 times by 9 on 10 to the power of 8 minus 1. So if I plug that in my calculator, 120 times by 9 over 10 to the power of 8 minus 1 gives me roughly 57.395 kilometers. On which day do they ride this? Okay, so that's our answer here. Now we've got to answer this one. So let's get rid of all this. So this is your T of n they've given you in this case here. So T of n is 30.5, and we're trying to find out what n is, because n is the number of days, and it's going to be less than 8 because it's slowly decreasing over time. So we have T of n equals T of 1 times by r to the power of n minus 1. So now we have 30.5 equals 120 times by 9 to the power of 10 over n minus 1. Divide both sides by 120, so 30.5 divided by 120 gives me, oh, that's a yucky number. I'll write it as a fraction, 61 over 240, and then we have 9 on 10, n times by 10 on 9. So what I did there is, alright, 9 on 10 to the power of n minus 1 is the same as 9 on 10 to the power of n times by 9 on 10 to the negative 1, which I can just flip to 10 on 9. Okay, I'm going to rub this out now because I don't need it anymore. Plugging this in, so now we're going to have 61 over 240 times by 9 on 10, because I divide both sides by this, by multiplying by 9 on 10. So that's why it's on this side now. And then I have 9 on 10 to the power of n here. Okay, I'm going to work out what this is with our calculator. 61 over 240 times by 9 on 10 gives me 183 over 800 equals 9n on 10n. Okay. I don't think I'm going to be able to work this out without doing logs now. Mainly because that ratio won't really work out. So what we can do is go and work it out using logs. So we can go natural log of 183 over 800 divided by natural log of 9 over 10, which gives me n equals that. Okay, so if I go, oh sorry, I didn't write this down, so natural log of 183 over 800 gives me natural log of 9 on 10 to the power of n. I can move that n down the front, so I'll have n natural log of 9 on 10 equals natural log of 183 on 800. So that means n is going to be natural log of 183 on 800 divided by natural log of 9 on 10. So n is approximately 14 days. Okay. I thought you'd be able to do it without logs, but you have to with this last question. Actually, no, there's one more. If you have any questions about this one, leave something in the comments. Now, the reason why it's going to be approximately is because I have a feeling there's a couple, I feel like they're rounded with this one. That's why it's going to be like 14.0007. But yeah, that's the only reason why it's not fully whole. But anyway, let's move on to the last question. Okay, so consider the geometric sequence here. So 1, a squared, a cubed. So it's getting times by r is a. Suppose the sum of the two consecutive terms in the sequence gives the next term in the sequence. So in other words, 1 plus a gives you a squared, and a plus a squared gives you a cubed, and so on and so forth. So it means the sum of the two consecutive terms, so these two are one after the other, that's what consecutive means, gives you this term here. So this is what they're saying. Find a. Okay, this is pretty easy. So we have a squared minus a minus 1 gives you some quadratic formula here. So what we can do is, alright, let's see if we can factorize it. So two numbers that multiply to give -1 and add together to give -1. Well, that's a bit of a conundrum. We'll double check our quadratic formula, a, b, c. So we have 1, -1, -1. So delta is b squared minus 4 times a times c. Delta gives you -1 squared minus 4 times 1 times by -1. So you have 1 plus, what's this going to be? 4. So you get 5. Okay, so it's not going to be a whole number pretty much. So you need to work this out in the quadratic formula. So just finishing off, x is negative b plus or minus delta 2a. So x equals minus 1 plus or minus what we just worked out here, all on 2a. This a is talking about this one here, sorry. I've got to replace that with 1. So that means a is going to be 1 plus or minus root 5 on 2. Okay? So a is 1 plus or minus root 5 on 2. Okay? Now we've got to think, alright, can this work for both positive and negative? Well, we can double check. If I have 1 plus root 5 on 2 plus that all squared, does that equal that cubed? Now, this number looks very familiar. For example, if you've ever done the golden ratio, you probably know what this is. But we have 1 plus root 5 on 2 plus 1 plus root 5 on 2 squared. Does this equal 1 plus root 5 on 2 cubed? Okay, so let's work out what this would be. So the left hand side, 1 plus square root of 5 on 2 plus 1 plus square root of 5. I've got to do brackets around all that. On 2 all squared. So the left hand side gives me 2 plus root 5. This side I'll go brackets 1 plus square root of 5 on 2 all cubed, and that also gives me 2 plus root 5. Okay, now the negative number, we'll double check if that works as well. Negative, and sure enough it does. So both answers work, and that's pretty much the golden ratio. You can take a bit of a look at that if you Google golden ratios, but that's it for this video. I hope you enjoyed it. If you have any questions, leave something in the comments and I'll try my best to answer them. I'll see you in the next one.